this computer. It's time for Arrested DevOps, the podcast that helps you achieve understanding, develop good practices, and operate your team and organization for maximum DevOps awesomeness. I'm Bridget Krumhout with a great show for you today, but first, a word from our sponsors. Okay, so we've talked before on this podcast about Kubernetes and service mesh, but we can get more complicated than that. So to talk about this exciting topic of multi-cluster service mesh, what even is, we have two guests, and I'm going to ask each of them to tell us a bit about yourself, like where you live, what you work on, what surprised you the most when you started looking at multi-cluster service mesh, starting with Phillip.
All right. Thanks, Bridget. Hello, everyone. My name is Phil Gibson. I'm a PM here at Microsoft. I'm focused on our cloud native security projects, OSM, Open Service Mesh being one of them. And I live in Atlanta, Georgia. I'm originally from Chicago, so go Bears. And I've been collectively with Microsoft for about 13 years, or coming up to 13 years.
Nice. All right. So incorrect NFC North opinions aside, go Pack go. I'm really I'm really excited to have Phillip here giving us his insights, because I think he spent a lot of time looking at how specifically how end users use things in this space, which ends up being key. For those of us who work at vendors, it's like, hey, it's awesome that you want to develop some software, but how is it going to get used? And that is actually that specific topic is why I'm also excited to introduce our second guest today. Annie, you're on the last week of summer internship with this team, being mentored by Phil. And I'm wondering if you can tell us a little bit about yourself, where you live, about school, what surprised you the most in this internship?
Yeah, definitely. Thanks, Bridget. I'm Annie. I'm a PM intern on the team this summer working on Multicluster. I am originally from the San Francisco Bay Area, but I'm a rising junior at UPenn, and I'm studying computer science with a focus on cloud computing. And yeah, I think the most interesting part of this internship for me was just getting to work with an open source community and seeing how being a product PM on an open source team is different from being one on a regular product team. So yeah.
Fantastic. Okay, so for those who have listened to this podcast for a while, we've done a number of ADO episodes about Kubernetes, including one last summer explaining service mesh with Michelle Nourley and Delian Raychev. So arresteddevops.com/service-mesh, you can go listen to that one if you want the intro. We're going to be at kind of a 201 level here today. The exciting topic of multi-cluster service mesh. Phil, I'm gonna toss it to you first and say, what does that even mean? And show your work.
Yeah. So multi-cluster, right? I guess at a high level, probably the most accepted or popular description of a multi-cluster is a multi-cluster service mesh is the ability to be able to manage multiple Kubernetes services connected, in the east-west communication flow across multiple clusters, right? And as I'm saying that probably sounds super convoluted, right? But I think, what we found and we'll probably get into this, just, the discovery of, hey, who needs a multi-cluster service mesh? It means a lot to a lot of different people, and it's really kind of like trying to figure out what that true definition is and what problems we're trying to solve, for people trying to consume like a multi-cluster service mesh or service mesh in general, right? So I'm a bit rambling right now on this topic, unfortunately.
That's great, because I think you hit upon what I think is a really important point, that being, what are people trying to do? And you also mentioned something that I'm gonna toss to Annie and ask her to explain for our listeners. who hear east west and think north, south, east, west. Wait, what do those things mean in a cluster? Annie, do you want to kind of give us a little bit of insight into what exactly the directional stuff is?
Yeah, so I'll first start off by talking a little bit about what happened before multi-cluster functionality. So what Phil talked about, something called north-south traffic, where traditionally, if you have two clusters and you have pods inside one cluster with services, pods will have to exit that cluster to access the services of the other cluster, cluster B. But then now with east-west traffic, we're enabling the ability for clusters to not have to, or pods not to exit that cluster to talk to those the services, so they can access the ingress of the other cluster without having to exit either cluster. So yeah.
So that opens up so many questions. Like, do these clusters have the exact same security model? And how do pods know which stuff in the other cluster they should talk to? Like, how does that work?
You want that, Annie, or?
I'll throw it to you, Phil.
Yeah, I mean, typically what we're talking about now is if you're familiar with kind of how Kubernetes works and this whole notion of a control plane and then this data plane where a lot of the traffic is happening, and the control plane is where the operators are configuring configurations and everything. Being able to take that control plane functionality, so how you're configuring your cluster, extending that to a service mesh, and then having that control plane distributed across multiple clusters as well. So that's kind of almost step one, is making sure like you're able to control and do all your CRUD operations for your mesh across a distributed architecture there. If one system goes down, you still have access to it. And then two, again, kind of what Annie was talking about, the north-south, east-west communication. Now we have essentially a method to where, you have services in one cluster can communicate, again, I guess we'll say horizontally across multiple clusters without having to go through kind of like, or enter in through a normal like ingress. Wow, just as I'm talking about this, it's like how deep do we want to go, right? Because you got ingress, the traditional ingress controllers, which, if you're familiar with Kubernetes, hey, that's how you kind of expose your service out to the world. But then with multi-cluster service mesh, we now have a concept of an ingress for the service mesh, right? So again, not going through those traditional ingresses, but going through a more east-west ingress, where then we're populating routes and everything else.
So when you say it's ingress, but it's different, and then you say east-west, my mind immediately goes to, gosh, coming in from the side. Is this at all as dangerous as side channel attacks? Exactly how do you connect these clusters that may have different security models? Like in a multi-cluster scenario, do both clusters need to have all the same access to all the same everyone's, or is there a way to set any access more granularly?
Yeah, for sure, right. So I think, the cluster itself can be a security boundary. So you'll definitely be able to, within your cluster, have its own sort of RBAC controls or policy controls, et cetera. I guess, we're using ingress as the raw term, which means to kind of enter into, right? And instead of, again, that traditional, what we all know of an ingress controller, the popular ones out there, which are exposing services to something that's coming into the cluster. Same concept is just, for the service mesh, we're saying, hey, we're going to have a incoming ingress on a additional cluster that we're able to populate routes through, have that configuration kind of sync through the control plane that's going across all these clusters, so that service A that's in cluster one that when it needs to get to service B in cluster 2, it knows that, hey, I actually take this route, and that's going to end up touching this ingress that is strictly just related to the service mesh, and it gets routed out of the cluster that way.
Gotcha. So this all, I'm not going to lie, sounds very complicated. And I thought Kubernetes was hard. So I think, Annie, you have a great blog post. So I think, Annie, you have a great blog post you wrote talking about conceptually from a high level, some of the benefits of multi-cluster. And I think Phil hit on a few of those, but maybe you can kind of lay out for our listeners, why would someone want to do this stuff that sounds frankly kind of like a lot? What are the wins?
Yeah, for sure. So yeah, I think Phil talked a lot about east-west traffic and how that's different from what was traditionally done. But some other benefits include before a service mesh only runs on one Kubernetes cluster. So you're limited to the size and scale of that Kubernetes cluster. But by enabling the ability to deploy services to multiple, you're allowing your applications to be scaled more horizontally as well. And I think another big benefit has to do with disaster recovery and failover. So one aspect of that would be the ability to deploy the same service to multiple clusters, and that enables some sort of failover if something happens to a single cluster. And something else that is also possible would be being the ability to redirect traffic away from unhealthy clusters. And this helps minimize damage and makes sure that your workloads are still running.
Okay, so wait, I'm gonna pause you right there because I'm hearing things that we've heard before. I'm hearing, oh, load balancing. And I think, okay, load balancers, we're familiar with that, but it's load balancing against entire, like, a whole bunch of different clusters are behind your conceptual load balancer. Or like canary deployments, blue, green, that sort of thing. We've heard that before, but now we're hearing, instead of just, pods or services or whatever, you've got entire clusters behind these. Is that the right framing?
Yeah. So the idea is if you have one unhealthy cluster, you're able to divert traffic away from that unhealthy cluster towards your healthy clusters. So, and that enables some sort of failover.
Hey, and then there was a little bit more, I think, that I interrupted you, but I was like, we got to get a little more clarity here. But what else do you got for us?
And I think the last impact is could be zero downtime between Kubernetes upgrades. So if you have multiple clusters running services, and you need to upgrade some of those clusters to different Kubernetes versions, you can ensure that your workloads continue running as you're updating your clusters by updating them one cluster at a time. So yeah.
So that sounds great, except that so that sounds great, but I have read the Kubernetes release notes a few times and quailed at all of the API deprecations and breaking changes and this, that, and the other. I'm going to look to you, Phil, and say, do we have any kind of gating or like, oh, okay, we're going to do a zero downtime cluster upgrade, but then these APIs work over here and these ones don't work over there. Like, how would a multi-cluster scenario handle differences between the clusters?
Yeah, you're getting into it now.
Like, this is the hard stuff, but I want to know, what are we thinking?
It's funny when we get to this level, because I think, the value of or what made Kubernetes so popular from the start is it's offloaded just a lot of labor intensive, configurations, so we like what we're talking about now, load balancing, scaling applications, automatically putting like runtimes on distributed resources. And I think we kind of take for granted now, because we've just grown accustomed to like having this functionality is default, right? But it's doing a lot under the covers. So when you're talking about a multi-cluster service mesh and specifically around APIs, within the mesh itself, obviously there's controls and webhooks of things that it's going to reach out and do. If you're talking about like your application, like if I'm exposing my application, it has certain paths and APIs. You can also kind of blend that into your config as well. And you know, those are things that we are currently working into the service mesh too, because you know, again, customers or users, you know, the chemistry set is cool, right? But I think, you know, people really want something that's simple and easy to implement. And so I know in our journey and us discussing multi-cluster inside of OSM is really, hey, how do we keep this, the experience super simplified so that we kind of shield you from kind of all the heavy lifting that goes on. So there's still a lot to be imagined there, and we're still kind of working on how best to make that experience.
Yeah. Yeah, I think that Annie had some stuff she wrote about the philosophy. I would love to hear what's your take, Annie, on coming into this project and wanting to give people the experience of, you know, reducing the complexity, like Phil mentions.
Yeah, I think, yeah, like Phil mentioned, and I think I talked about it briefly in my blog post, but we really wanted to align with sort of the OSM philosophy of making things really simple to use and to configure. So our philosophy for multi-cluster is to sort of enable these complex, larger use cases while still maintaining a really simple and easy to use experience.
But hey, you know, complexity is conserved, so it's going
Yeah.
somewhere, apparently into a bunch of YAML, or is there still YAML here? Everything is YAML, right?
There's YAML, there's config maps, there's new CRDs, all the above.
You get all the everything. So I want to switch gears for a minute here and say, now this was an exciting new experience for our team having an intern working with us on this. I think it was probably also kind of an interesting experience for Annie to come in and start working on this project. Annie, I want to hear a little bit from the point of view of you weren't already steeped in the Kubernetes ecosystem and having service mesh opinions, TM, and all that. What did you think when you got this intern assignment? Like starting from what is a Kuber what? Like what were you thinking when you looked at this?
Yeah, I think, yeah, I was definitely very overwhelmed. So many words, like Kubernetes, service mesh, even things like, yeah, simple things like OSS. I had no idea what that meant. So yeah, I think it was a very overwhelming experience to start, especially because in university, since Kubernetes is relatively new, you don't learn about stuff like that in school. Yeah, so I think the experience of, I think being an enterprise PM was interesting, working on sort of more technical projects, because I, like you said, don't have a starting opinion on a lot of these. I personally am not a service mesh user. So yeah, I think getting to talk to a lot of different people who use service mesh or people who have experience in service mesh was really interesting and valuable. Just hearing what they liked about it, what they didn't like about it, things that they think that could be improved. I think that was a really great opportunity to kind of increase my knowledge in service mesh and really valuable to my internship too. So, yeah.
Nice. And I so and you touched upon that discussion. Of course, you're talking out there to people in the community and users, enterprise customers, et cetera. And I think Phil has spent a bunch of time kind of looking at this line between project and product. What would you say, Phil, is your approach for when you're figuring out this is something that needs to be a product offering, this is something that should be in the open source project? How do you approach that?
Yeah, you know, I would say initially I probably approach it the same way. You know, for us, the benefits of open source are tremendous, right? That project is either going to live or it's going to die on the vine, right? So what immediate, you know, what better way to have some immediate feedback than to share it with the community and see if there is a following for it, and that it's answering a need for a lot of people, right? If it's just something that is kind of a simple add-on to something else, then maybe it won't get that traction. But I think we really try to focus on, hey, what are the gaps out there? What are the pain points that a lot of customers are talking to us about? Those conversations where you say, hey, I only wish it could do this. When you start to get a bunch of signal on that, you start to think like, hey, there's probably a need for some type of functionality around this. We're getting multiple signals from different types of customers, et cetera. And then it's really about us trying to figure out, you know, us kind of like, how are we going to create this and expose it to the community, et cetera. So yeah, no, I think what better way to either know, hey, this is something useful or this is something that is not useful than to share with the world and get some feedback. So definitely you got to have thick skin in the open source game, right? Because and you really a lot of the times a lot of the criticisms they could get you, but the fact remains there's just maybe some truth behind those criticisms too, and those need to be listened to as well.
Yeah, that's a really important point. I think that we're all learning when we're working in public,
Right?
And we're not just releasing something that is correct and right, because
Yep.
why would you be working in public if you didn't want to learn from the community? Yeah,
Absolutely.
So Annie, I know you've participated in a bunch of community meetings, as well as customer calls, and written a blog post. I'm wondering if you can kind of talk a little bit about the side of the product work that is this open source, that is this community, that's GitHub, et cetera. What you've learned about that.
Yeah, I think the biggest thing that sort of was interesting was just like the challenges of building features in open source versus product, and being able to find that customer or the need, like Phil said, just sort of like rallying the community to really throw things out there, and seeing if they not stick, but if they solve an actual problem. And I think that was interesting to me, where I think on more mature products or just traditional products, you have a very defined group of customers that have a very defined need, and it's easier to sort of figure that out. Whereas in open source, you have this huge community, and everyone's using these projects for different use cases. And I think it's really interesting to kind of go out there, rally the community, and also sort of find the niche within the open source community that actually needs what you're building. So yeah, I think that was the biggest thing that I learned from the open source community, where yeah, it's just how to rally the community to figure out if the problem you're solving is something that someone actually needs. And that's actually why we did release the blog post, just to invite discussion on Multicluster, and invite people to come talk about it with us and work on it with us, so that we can figure out if it's a project that solves a really big problem for people. Yeah.
Right. And I know, Phil, you have an agenda item on a forthcoming service mesh interface spec community call, just about like, hey, what are some of these ways we're evolving this spec in the public? Can you talk a little bit about like the spec versus implementation, and where you see the best places to push changes, Phil?
Yeah. I think the spec is important, right? And I'm assuming we're talking about the service mesh interface spec. So the SMI spec, for those that aren't familiar with it, right?
We'll have a link in the show notes.
Yeah. And I think what's cool about their project is there's no code, like as far as like the spec is concerned, right? So we always get people like, well, where do I go download this? Where do I go? And we have to clarify and say, no, this is kind of this agreed upon specification of how this APIs are to interact with things, right? And to me, that's totally core to a lot of things, right? Because if you can't agree at that point on kind of what APIs should make things available or light up features, then most likely any project tied to spec is not going to fail. So it's been a, I wouldn't say challenging, but because again, we're trying to get this consensus of like this whole large community to agree on a lot of different things, right? And hey, some of those checklists, they happen quick, and a lot don't happen as quick as we want them to. But we're listening to the community to kind of tell us, hey, where does this spec need to go, and what are the most important things that need to be bubbled up for us to really enhance the specification. And I just think it's just a good hygiene to have in any open source project.
Yeah. And I agree. And when you talk about listening to the community, there's an interesting nuance there, because as Annie alluded to earlier, not every member of the community needs multi-cluster service mesh. Annie, you want to address that a little bit more? Just like what kind of applications or customers or end users are looking for something like a multi-cluster service mesh?
Yeah, for sure. Yeah, you bring up a really interesting point, because a really interesting thing that happened during my internship was, in the beginning, I was exploring users who would need it and what the problem is. And yeah, service mesh is a relatively new concept. So some people are just beginning to use it, just beginning to explore how they can use a service mesh in their applications, and finding the need for multi-cluster where someone would benefit from the scaling, the failover that was difficult at first, because every user we talked to had relatively simple applications, and they were just exploring how to use service mesh. So yeah, I think, Phil, do you want to talk a little bit about the more specific applications of it?
Yeah, let me just add to what you laid out there, because I think you nailed it, right? And Annie and I, we went into this and we were thinking, hey, everybody wants a multi-cluster service mesh, right? Like that was our default. Like, and a lot of that it stems from just the enterprise mind state, right? Hey, I got a very critical application. It needs to be distributed. I'm using the service mesh, then obviously I need to have a service mesh that's distributed as well, right? So it comes from a good place. But I think what Annie and I found out in this journey is that the need for a multi-cluster service mesh was kind of directly tied to your maturity with Kubernetes. And what we found out is that, hey, if you're brand new to Kubernetes, multi-cluster service mesh is probably so far away, because hey, you've probably just refactored some application that was running on the VM. You finally got it into a container, hooray, and now you just want to expose it out port 80, right? And then have people come shop at your website. And then
port 443 as well.
Yeah, 440. Yeah. Make sure things are secure. Make sure you got your certs. And then I think from that, then you start building muscle. And I think probably the next step is, okay, how more apps can we onboard to the cluster? So I think, again, initial step is, hey, we're using Kubernetes. Oh, this is great. All these built-in features, scaling, et cetera. Let's just add to the cluster. Let's just grow the cluster horizontally and onboard as many apps. Right. And it's funny, like I remember, I don't know, a year or so ago, I was reading about like the Alibaba cloud, like they had a cluster that had, I don't know, was it like a million pods, like just some astronomical number. I'm sure someone will correct me, but I just know like the number of nodes and pods was just like insane, right? And so then you have that, but then again, now the enterprise is telling you, hey, we need to have a region here in this location. We need to have another region there, and we need to have these apps, distributed, in case something happens, region goes offline or whatever the case may be. And by the way, we're using service mesh. And again, we're going to need that in these other locations. Not to mention, let me just back up, not to mention that some people don't even need or know that they need MTLS, right? So again, I made that example of
Oh,
they
did
just
you, do
kind
you
of
want to, I feel like we should gloss that for our listeners. Want to clarify what is MTLS in this
yeah.
context?
So this is kind of I don't say it's a source of confusion, but when we talk about it, then people are like, oh, okay, yeah, maybe I do need that. So think about like how the world works today. We talk about port 443, right? So TLS, hey, I go to my favorite shopping website. There's a little lock there. I know that, hey, if I put in my credit card info, that channel is secured, right? So that's kind of a uh, I wouldn't say one way, but it's just say one person has been basically validated of who they are by some other source, right? And that's who gives you the certificate, and that's why you trust them, where you can put your credit card in. When we talk about mutual TLS, right? So the M is mutual, so it's TLS, same tech, but now what we're saying is, hey, not only am I trusting who you are, you're going to trust who I am too, right? So think about your favorite website that you shop at. Not only are you okay with putting your credit card and the details in your browser, but what if they knew, hey, you're Phil Gibson and I trust you to even shop with me, right?
Mm.
And so that's where we get the MTLS. So I've been through some iterations on that analogy, so hopefully that resonates with a bunch of
Helps.
people out
Yeah.
there. If not, let me know, give me some feedback, and we'll come up with a different one.
Mhm, mhm. So that actually brings up an interesting question that I'm gonna toss to Annie, which is there's an awful lot of acronyms, terminology. The fact that Phil has very clearly pointed out, not everyone needs multi-cluster service mesh. Not everyone needs service mesh. Maybe you're just starting to need Kubernetes. Like as you layer all those pieces in, which ones do you think you're going to take back to school, talk to people about? What I learned on my summer vacation is Kubernetes. Like, which stuff do you think is going to resonate with everyone you're interacting with in a college, computer science program?
Yeah, I definitely think service mesh is so new and so far out there. I probably won't be bringing that one up that much, um, especially multi-cluster specifically. But yeah, I think Kubernetes is really interesting. There's so many use cases. Yeah, and at school we still use VMs for anything. I'm a cloud computing focus, and we don't use Kubernetes. And that's because Kubernetes is a relatively new thing. It was developed within the last 5 years. So yeah, I think I'll definitely be bringing that one back to school, telling my classmates about it. And yeah, hopefully in the near future, it'll also get incorporated into some curriculum.
Yes, that's so interesting to think about. Like, of course, everything in the academy, as it were, is going to both be presaging everything we're doing in industry because it has innovative research, but then also lagging in that it's not that everyone can redevelop a curriculum on a dime and suddenly have a curriculum that incorporates everything that, Phil blogged or talked about at a conference last month. It's not going to all make it into a curriculum for this fall. Like it just isn't. So
Yeah.
so
Yeah.
how do we bridge the gap there? Like, do you get Phil to come in as a guest speaker for one of your classes and, get him like telling some of the cloud computing students about what's in their future? Like, how do we bridge that?
Yeah, I think, like you said, the industry changes so often, so it's impossible to, face each year's curriculum off of whatever new thing is going on at that moment. But yeah, I do think that university does teach you the fundamentals to be able to go out there and learn about it. So yeah, I have enough experience as a CS student to be able to come here this summer and get an understanding of what Kubernetes is, what service mesh is. But yeah, I think for college students, especially in their later years, to just be aware of what else is out there in the industry, going out there and doing internships like this just really helps inform them on what's in the industry. And then I think university is really for building those bottom line skills that really help you learn whatever it is you need to learn later on.
Yeah, if you, Phil, I'm just kind of curious what you think, because I'm listening to Annie and thinking, you know what, we all hopefully are learning and should be learning and are trying new things all the time. Like, do you want to kind of, as we wrap up here, kind of give us your perspective on, you've been at Microsoft for a while. You obviously have not been focused on multi-cluster service mesh that entire time. Do you want to give us a little sense of the journey so people can imagine themselves following a journey like yours? Of like
Oh,
which techs you
specific
focused on over
to
time?
mine. Yeah, yeah. I mean, I was just going to touch on something. So, like, I really commend Annie, right? Because when we got an intern, I was chatting with my boss, Lockie Evison, if you know him, and so we were kind of going back and forth, like, okay, where can we insert the intern that kind of help us do things, right? And we thought multi-cluster. We thought, like, okay, do we want the intern to have a fun experience here at Microsoft or not, right?
Are we giving
But
the intern the hardest project?
yeah, yeah. What's the hardest thing that we're dealing with right now? And so yeah, let's give it to the intern coming in. But no, I mean, Annie's been awesome, and I think you can hear from what she's been talking about today. And I think that's kind of evidence of how really motivated she was to kind of get in and kind of understand what this whole ecosystem is about and what is this whole feature set about. So yeah, I hope, Annie, you kind of spread the word there with you go back to school. But yeah, I guess back to me. Yeah, as far as my journey, I would say if you are a technologist at heart, just follow your passion, right? I'm using passion again. For those that don't know, I mean, I'm was considered a boomerang here at Microsoft, meaning I left and I came back. But I left and I went to work for Docker, and I was at Microsoft, and was someone had mentioned containers. I didn't really know this is years ago. I was like, well, what is this whole thing about? Like, what's wrong with my web apps, etc. And I went through like their tutorial, and then this light bulb came on. I was like, whoa, this is pretty slick, right? And then I kind of just devoted maybe the next portion of my life to understanding Docker and how this can solve a lot of issues for a lot of the enterprise customers at the time, right? So that was a great experience to be at Docker, and then to come back to Microsoft and kind of bring that experience and bring kind of what customers are, what the advantages are for them to be in a more cloud native computing environment. Um, so yeah, I mean, I think if you're passionate about something, go for it. Let that kind of drive your avenue as far as where you want to take it, and then most importantly, no, it's okay for you to be passionate about something, but then again, for open source, see how you can enhance it. I think that's one of the things a lot of people don't think of is they'll come in, they'll consume Kubernetes, they'll consume all these other open source projects, but and they may have super intelligent ideas about things. And when I say contribute, that doesn't mean, hey, you're sitting down writing tons of lines of code, but just an issue out there and say, hey, how come it doesn't do this or that? And you'd be surprised how we would still call that a contribution to the
Oh,
community.
yeah.
And
Oh,
then,
absolutely.
people who are have the time can pick something like that up and see if it's worth it.
I'm just, when I think of open source contributions, I think of how you, Phil, wrote some really long documentation on the Microsoft Docs site. And Annie came in and made a one-word PR that was literally just a clarification on the docs. And she thought, oh, should I put this in? This is one word. And I thought, you know what? This is an important clarification. Yes, you should absolutely put this pull request in and make this change.
Yeah.
Like that can sometimes be the most valuable thing of all, is removing a little bit of ambiguity or confusion.
Yeah, absolutely. Yeah, and I like how there's been this pivot or this embrace of people now being recognized as contributors who are just doing content, and not having to be, oh,
just making
okay,
it
yeah,
possible
yeah,
for
we're
someone to
making
use it.
content, yeah,
No big deal.
and not having to be, hey, I'm not this 500 level Golang expert or et cetera. But again, anytime that you can kind of soften the ride of someone who's new to come in and maybe read a doc and get through it faster than someone who's got through it prior to them, is a good thing, right, for the whole community.
Fantastic. Okay, so I think since you're mentioning docs, I'll say, what things would you recommend people read, watch, look at, etc., to learn more about this? And then same question, more about you and your work. We'll start with Phil. What should people look at?
I would say this. Just, if you're into multi-cluster service mesh, look and see what's all out there, right? There's other service meshes that are deploying their kind of way that they figure out multi-cluster. I would say just get familiar with the terms and the functionality in general, and then, spin up every mesh that supports it and just, comments on them, that would be my number one, is, again, just get familiar with the technology. I forgot the second half. I'm sorry.
Oh,
Was there
well,
something else? Like,
I was just saying, we'll skip that for the moment.
okay, it's on you. Yeah.
And Annie, what would you recommend people look at so that they can learn as you've been learning?
Yeah, I think, like Phil said, just to echo what he said, the value of being in an open source community is the fact that everything is out there for you to learn about. So yeah, definitely try all the other service meshes, look at their documentation, just to learn more about the ecosystem, what options people are offering, because that was definitely really valuable for me in my learning, where I didn't just learn off the OSM docs. I also got to learn off of all the other docs of all the other service mesh offerings that are out there. So yeah.
Fantastic. And Annie, if people want to catch up with you, keep up with you, follow your work, etc., find out, what Rising Juniors actually do and what Rising is. That's incoming, right? They changed all the words
incoming
since I was in school.
Mm-hmm.
Where can people keep up with you?
Yeah, I think my Twitter is in the bottom. So yeah, definitely follow me there. And yeah, I got to start my Twitter based off of the work I've done on OSM and Multicluster this summer. So hopefully I'll keep posting there too.
Very exciting. All right. And how about you, Phil? Where can people see more of your work or catch up with you?
Yeah, you might be able to find that on my Twitter handle. So at Phillip Gibson, Phillip 2 L's, spelled the correct way. But I'll warn anyone going there, you're going to see a lot of how to smoke barbecue. So just be prepared. There'll be some techie stuff, but don't be surprised when you see a couple of wrapped briskets on my Twitter handle as well.
But surely that's a feature, not a bug.
Yeah, that's it.
All right, fantastic. Well, I want to thank both of you for joining us. And I want to tell our audience, head over to arresteddevops.com/multicluster service mesh for this episode's show notes. Visit arresteddevops.com/iTunes. Leave us a review in the iTunes store if you want to help other people find the podcast. Narrator, I don't know how that works. We're also on Spotify and iHeartRadio if you're into those systems, which are apparently things. And Annie, Phillip, thank you so much for joining us today.
Yeah, thank you for having us.
Thank you for having us.
Awesome.
Super fun. All right, I'm Bridget at Bridget Krumhout. This is Arrested DevOps. And remember, there's always DevOps in the banana stand.